Hello guys, in this video I will teach you how to find the equation of a function from its graph. In this case we have a parabola and we need to find the equation. What we are going to use is the formula for graph manipulation. Here we have this magic formula and I will explain each of the parameters. The first parameter is the function g. G is the function that we are going to manipulate. In this example, we have a parabola that is x squared, but it can be a sine function, an exponential, or any kind of function. The other parameters are the parameters related to the size. We have here the x size, and we have also the y size. These parameters allows you to manipulate the graph either growing in the x direction or growing in the y direction. We can have also negative growth. For example, if we have a negative y size, it will be something like this. That means that you flip it and you move it down. The other parameters that are also very useful are the displacement. Here we have the x displacement, that is how you move the center of the graph, and the center is this point that is 0, 0. The x displacement, it means how much you move this point to in the x direction. And the other, that is the y displacement, is how much you move this point, the center again, 0, 0, in the y direction. Okay, now that we know how the parameters work, we're going to solve the example. In this example, we have a parabola. Here is the parabola, and we are going to manipulate the regular function of a parabola. So the first parameter that we are going to find is the value of g. What is g? G in this case, let's write it as g of x, is a parabola that is x squared. The graph of this parabola is this one, right? Because it's 0, 0 the vertex, then it grows up to 1, 1, then 2, 4, and so on, and on the negative side is exactly the same. Now, for having the other parameters, we need to find like a reference that we're going to use to manipulate. In this case, I like to use the reference this part, that is the central part of the parabola. Why? Because the center is here at the vertex. We have the point 1, 1 and negative 1, 1. We need to identify the same reference here in the parabola we want to find the function. In this case is this part. The points are different. Now the center is 3, 1, that is the vertex, and we have points at 6, 3 and 0, 3. Now let's find the parameters. We have g of x, that is the parabola. Now the x size, usually the size of x is here from negative 1 to 1. That means that we have a size of 2. In the case of this parabola is from 0 to 6. So now it's 6. If it was 2 and now it's 6, it means that it grows 3 times. So the x size is going to be 3. Now let's find the next parameter, that is the y size. The y size is how much it grows on the x direction. Here, the reference, we have a size of 1 because it's from 0 to 1. And down in the parabola we have the size, that is this, is from 1 to 3, so it's 2. That means that the y size for this parabola is 2. We're going to do the same for the displacement. The displacement of x is how much we move the center. In this case, the center is in 0 in x, and for this one is in 1, 2, and 3. Here we have the center on x. That means that 3 is the x displacement. X displacement equals 3. We're going to do the same for the y displacement. Again, the center is here, and we are going to know how much we are moving it up. For this parabola, here we have the center that is at 1. So at y equals 1. That means that the y displacement for this parabola is 1. Now that we have all the parameters, we can write the equation of this function. Once having the parameters, we need just to plug in the values in the formula. So let's write the formula. F of x, that is the function that is equals to y, is equal to the y size. In this case, the y size is 2. Then we need to find g of, instead of being g of x, is g of all this. This means that we are using function composition. Remember how we do function composition? Instead of writing the function x, we write parentheses, and inside the parentheses we just write what we have here in green. In this case is 1 over the x size, that is 1 over 3, times x minus the x displacement, that is 3, 2. And now we need to write the y displacement, that is plus 1. Here we have the function, however we need to simplify it. What we need to notice is that we have this 1/3 and this other factor squared, so we can make each of them squared. This is what we are going to do now. So we write y equals 2, and 1/3 squared is 1 over 9. Then we have x minus 3 squared, and we have the plus 1. That means that we have y equals 2 over 9 times x minus 3 squared plus 1. And here we have the canonic form, that is the easiest way to see the equation of a parabola. Finally, take some time to find the equation of these two parabolas. So remember, here at the corner you have the parabola that you can use as reference for manipulation. Pause the video and do it. Okay, I hope you have done it. I will explain how to do both of them. So, first, let's start with the first one. We are going to mark what we are going to use from this parabola as a reference. I like to use the center part. So here, in the first exercise, this will be the center part. So now, all the parameters. G of x. G of x is the function of the parabola, that is x squared, that corresponds to the function that we are using as reference. Then we have the x size. The x size in the first in the reference is from -1 to 1. As you can see in this other parabola that we are manipulating, is the same, from -1 to 1, so the x size is 1. The y size for this parabola is 4. Why? Because usually in this reference is 1, because it's from 0 to 1, and in this reference is 4, because it's from 0 to 4. And also we can see that we flip it in the y direction, so that's why it's not 4, it's -4. We can also find the x displacement, that for this case is 0, because the vertex remained at the coordinate x equals 0, and the y displacement, that for this case is 4. Why? Because we are moving the vertex up to 4. Now that we have all the parameters, we plug in the formula that says y equals to the y size times 1 over the x size, so 1 over 1 is 1, so I'd avoid it, x minus the displacement is 0 squared, and then plus the y displacement, that is 4. So if we simplify it, is -4 x squared plus 4, and here we have the answer for the first one. For the second one, what we're going to do is to mark again what we are using as reference. For this one, I would like to use this reference. You can use another reference if you want, but this is the one that I am going to use. So again, we are using g of x equals x squared. Why? Because x squared corresponds to this graph, the one we're going to manipulate. So first of all, the x size. The x size usually is from -1 to 1. In this case, it's from 2 to 6. So it's 4. That means it grows twice. Here is 2. In the reference is 2. And now it's 4. So that's why it's 2. Then the y size remains 1. Here in the reference, here we have the reference is 1. And here is also 1 because it's from 3 to 4. So the x size equals 1. The x displacement, in this case the coordinate of the vertex is 4, and in x and also in y. That's why we have both displacement as 4. And remember some mistake I did, because this we flip it down. Actually the y size is not 1, it's -1. Remember that, is important. Now we follow the formula and it says the y size, that is -1, times the function, that the function using function composition is x squared, in this case parentheses squared. We're using function composition, remember. And instead of x, we write a parenthesis. Then we write 1 over the x size, that is 2. So 1 over 2 times x minus 4, because it's the x displacement, plus the y displacement, that is 4. Then we simplify it. It's going to be -1, and 1/2 squared is 1/4. And then we have x minus 4 squared and plus 4. So that means that y is equals to -1/4 x minus 4 squared plus 4. And here we have again the canonic form, and I hope you have done it right.